this system was brought in for no display issue, and upon powering the system, this is the consumption I'm getting. If I'm getting this kind of consumption for this carcass of system, I mean this generation of system, this is trying to tell me nothing but my laptop is already at display level. So conclusively, what would I do? If I have display issue, the first thing I will confirm is my board caps locking, if I'm good to go on my DC. Here the board is caps locking and yet no display. We've removed this screen and we've tested it with our screen tester, and this is it. So what I'm going to do next, since this screen is working perfect, is I will open this board and I'll start the troubleshooting from the motherboard. I'm sure the problem will be within the LVDS section. So now I've opened the laptop and I'll power the laptop again. So I've powered the laptop and it has turned on. Still no display, and I'm sure my board is still caps locking with this consumption. So what I'll do next here is I will off the board, disconnect this hard drive, or let me leave the hard drive. Oh, let me disconnect the hard drive, because I don't want situation whereby the hard drive will be damaged. So 100%, since I've removed the hard drive, the consumption will be different. So now again I'll power the board and I'll give power. Now this is the consumption. Let me check if it is caps locking. Okay, still caps locking. The consumption has only changed because I've disconnected the hard drive. So what I will do next is I will check the requirement of this section, and to do that I will have to go through this board schematic, and this board schematic is LA-E881 LA-E881 under the, I don't want to open this, but I've seen it. So if I should come to my system here, LA-E881, I can just punch in sorry, 811. This is it, LA-E811. So this is it, and I'll be going to the LVDS section of the motherboard, because the problem I'm treating here is LVDS issue. This is JEDP, so I'll punch in JEDP here, JEDP. This should take me to the LVDS section. Okay, here, this is the LVDS section of this motherboard, and let me zoom it out. Yeah, this is it. So what are the requirements of this section? Firstly, the basic requirement of this section is nothing but the main 19 volt that comes through this place, the LCD VDD signal, and ground. So here, this is the 19 volt rail, pin number 19 and 20, and for the LVDS, let me scroll down. Okay, nothing more. For the LVDS, this is this LCD VDD, that is the name used here, pin number 9 and 10. So I'll go on my motherboard and check these two signals before going to any other secondary voltage. So here, I'll turn on my motherboard. Okay, so now I'll check what is my value at pin number 9 and 10. This is my pin number 9 and 10. So nothing is on this pin, nothing is on this pin, pin number 9 and 10. Okay, no LCD VDD. So I'll go to pin number 20 and 19. Pin number 20 and 19. Okay, this one is present, pin number 20 and 19. So I guess the problem is coming from the fact that this 3.3 is not getting to this motherboard. So where is the 3.3 coming from? We can just trace from this place. LCD VDD here. Copy, paste. Okay, I think I found it here. Yeah, is coming through this component. This is UG1. UG1, it has 5 legs. UG1. Okay, here this is UG1. This is UG1 here, it has 5 legs. So the pin number 1 is the LCD VDD. Let me confirm that first. Again, still not present. What is the input? The input is pin number 5, that happens to be the VIN. That is 3 volt as well. Let me check. 1 2 3 4 5. This is the pin number 5. I have 3.3 volt present here. Okay, good. And pin number 4, do I have a label or not? Let me check. This is pin number 4 of the IC. This is 2.28. This enable is low. This enable is low. So I can backtrace this enable, or I just jump the input to output to check what is the status. This is my picker here. So if I should jump input to output, I should have display here. Now I've jumped it and nothing is happening on the screen. Nothing is happening on the screen. Let me confirm if it is really jumping or the voltage is dropping after jumping. Oh, hope this voltage is not dropping after jumping. I'll check if that part is short. Okay, I don't think I have my ground here. How can I? Okay, let me use. I've disconnected the hard drive. I need ground. Okay. Okay, thank you. Easy. Okay, the voltage is not dropping. This is 3.2 volt. The voltage is not dropping yet. I don't have display. So what I'll do now is I'll check other requirements, but before doing any other thing, for troubleshooting sake, I will jump this voltage from here to here, then I will continue with any other requirement. But before doing that, I will do the other version of this tutorial. But after doing that, I would have jumped this voltage, then I will continue there. So now we've led pin number 1 and pin number 5 of this AND gate. Okay. So here on the monitor, let me show you. Please handle the camera. Let me search. This will be simpler. Okay, not here. Here, this is it. We've jumped these 2 pins, pin number 5 and pin number 1, and still no backlight. Here, what I'll do next is I'll check what are the necessary requirements again. Remember I said those ones are the primary ones, so I'll go for the secondary requirement of this LVDS section for backlight. So here I'll check what is the value on my pin number 15 and 16. This is display off and inverter PWM. And this particular pin 20, 24, 25, actually these are not important, but one can just confirm for confirmation sake. So I'll go for this first, this pin number 15 and pin number 16. At pin number 15 here, pin number 5, 10, 15. At pin number 15 here, okay, I have not powered the board. This is my meter. This is my board. Okay. Okay, good readings. At pin number 15 here, 5, 10, 15. This is pin number 15. Wait. What do I have here? 5, 10, 5, 10. I need ground. 5, 10, 15. This is pin number 15 here, 3.2 volts. 3.2 volts, good. And this is pin number 16 here, 0.8 volts. This value is bad. So there are 2 things I can do here. I can backtrace the signal, and mostly this signal is always coming from the IO. And another thing I can do, the short method I can use here is to tap in 3.3 volt for this section. So since pin number 16 is having pin number 15 is having 3.2 and this one is having 0.8. The next thing I will do is I will jump the voltage and see if there is any changes, although we've done this in the other version. Here the LED is now present and my board has display. So what I will do from here is I will just jump pin number 15 and pin number 16 of this board. Or I should back trace, but I won't do the back tracing. So if you check this track very carefully, let me go under the microscope here. If you check this track carefully, this is let me see if I can make it more sharp. I think it's good like this. So where is the line? Let me count where if I can see the line here. If I can see the line on the board. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is pin number 15. This is the track of pin number 15 here. As you can see, this is the track here. Okay, and this is for pin number 16 beside it, as you can see here. Here. So this is 15, 16. So I'll just bridge these two jumper pad and I believe I should be good from there. But before doing that, I will reconfirm on my decks with picker. Powered, still the same thing. So where are those two signals? Okay, wait, this is 15 and 17. I think the flux has caused confusion. This is 15 and 17, so I can't do it there. The flux has caused confusion. So what I'll do is I will lead, because I actually don't want to come from this screen part, but at this point in time I have no choice than to come from there. So I'm going for pin number 15 and 16. I won't use flux. Okay, good. This is 5, 10, 15 and 16. This is 15 and 16. Yeah, I think that's good. That's 15 and 16. Okay, let me make it brighter here. So this is 15 and 16, perfectly bridged. So the next thing I'll do is to reconfirm. Yeah, now I have my display and everything is working perfect. So thank you for watching.